Hello, and welcome to day 14 of Leetcode. Today, we are going to be looking at today's Leetcode problem, which is 2294. It's called partition array such that the max difference is k. We're given an integer array and an integer k. We may partition nums into one or more subsequences, such that each element in nums appears in exactly one of the subsequences, and we need to return the minimum number of subsequences needed such that the difference between the max and min values is at most k. Okay, right off the bat, I don't understand this. Let's reread the problem. We're given an integer array and an integer. We may partition nums into one or more subsequences. Dividing into equal parts into one or more subsequences such that each element in nums appears in exactly one of the subsequences. 3, 1, 2, and 6 and 5. The max difference needs to be k. Difference between the max and min values is at most k. I think we need to sort this array like we did in yesterday's problem, right? That would make the most sense, no? It would make it a lot easier to deal with. Return the minimum number of subsequences. Return the min number of subsequences needed such that the difference between. Okay, so you want to divide it into the least number. So the max difference here is 2, and then 3 and 5. Derive from another sequence by deleting some or no elements without changing the order. So you can't change the order of them. So that would mean you can't sort them if it's... Ooh, this is not easy. But we're gonna do it. Max difference is 0? What does that even mean? Oh, 2, 2, 4, and 5. Wow. Oh, this is difficult. 1, 2, 3, this is just 1. How is this 2? Oh, because it's max and min value. No, you should be able to sort this, no? Nums.sort, okay. We sort them. This would become 1, 2, 3, 5, 6, right? But we probably want to sort it. We still want to see the original order, so sorted nums equals sorted nums. Make sure this works. 1, 2, 3, 5, 6. Okay. Yeah, they have to be in the original order. How do I even want to do this? We could iterate over the sorted numbers. Let's look at a hint. Which values in each subsequence matter? The only values are the max and min values? Okay. Does this need to be... It probably needs to be a very efficient solution as well. How is this 81% acceptance rate? Am I just missing something here? I think we need another hint. Sure, the only values we need are the max and min in each subsequence, but... The part that's really difficult for me in this is we have to keep it in the original order. It would be easy if we could just do 1, 2, and 3, and then 5 and 6, but it needs to be 3, 1, 2, and then 6, 5, right? Let's look at another hint. Let the max and min values of each of a subsequence be max and min. It is optimal to place all values in between max and min in the original array in the same sequence. What does that even mean? Let the maximum and min values of a subsequence be max and min. Sure, we have variables. Okay, we have variables max or sequence max. Sequence max, sequence min equals nums 0, num 0. Okay. It is optimal to place all the values in between max and min in the original array in the same sequence as max and min. Okay, so we go through this. We look at the first element. We know k equals 2. So when we see 1, this is sort it. I did. I sorted it. Yeah, but it's just like... It's just like, okay, you know the max and min for the sequence, but how do you keep it in the original order? Alright, I think I have sort of an idea. obviously we want to look at this first element and keep track of a max, and as we iterate through the sorted array, we want to keep track of a max and min that falls within k's boundary, right? So here, this would both be max and min. Here, this would be max and this would be min. Here, this would be max and this would still be min. And because this is the max difference we can have as is k, we want to now iterate through here and we want to see if the current element is within this range, and if it is, we add it to the subarray, right? We add it to the array. Oh no, we don't even need to add it to the array. Wait, yeah we do. Wait. I think we keep an array which has all of the subarrays within it, and then we just return the length of the result array. Result equals, so just an array. We initialize the variables to the first thing in the array, so the first element in the array, and then we iterate through the sorted nums array, starting at the second element because we already cached in the first element through the max and min initializations. So now if sorted nums I, if we're looking at this 2 here, we already stored this 1. If sorted nums I minus sorted nums I minus 1, but we need to keep it an absolute value, so just the difference between these two values, or no. Because what if it's descending? What if it starts at 6 and then goes to 5 and then 4? What are we comparing it to? Max. Oh, wait, so we just do sequence min equals just the min between the current sequence min and, why did I say num? And sorted nums I, right? Oh, but then if we're just doing one loop through, I don't think this would work though, because, no, it would. It would, because we're looking at a sorted array. If we were looking at this, okay, yeah. Because we're looking at a sorted array, we should be able to do it all in one go. Right. Sequence max is, I feel like this still... Okay, so this right here, this is both our min and max. Here, this would be our max, this would be our min. If we look at 5, I think we need to store the difference in a variable. Current difference equals max, and then we have these two values, right? Oh. My brain is hurting right now. Because I'm just thinking about this being, it can either, no, I'm so stupid. I'm literally so stupid. I thought this would, at some point, be descending, but it's a fucking sorted array. Oh my god. So the current difference is literally just sorted nums I minus, minus sequence min. I forget that this is a sorted array. If current difference is at most k, so it still can equal k. If current difference is greater than k, so the current difference is greater than k, so this would be, if 5 minus 1, that would be the current difference when we reach 5. It's greater than k. No, if it's less than k, right? Then we add it to the I think we do greater. If it's greater than k, because we can use slicing like the last problem did, because it's Python. If it's greater than k, then we know the element before this is less than k, and we can add it. Add from the min to here, right? Do we want to have the... But with slicing you need... With slicing you need the indices. Min index max index equals 0, 0. Then we want to result dot. Oh my god. I am literally so stupid. We don't even need to put them. We're not returning. Oh my god. We're not returning this. We're returning just the min number of subsequences. So that makes it like 10 times easier. Oh my god, I'm so stupid. Result dot append sorted nums, and we want to start at min index and at max index. Slicing Python and index. Stop. Exclusive. Always exclusive in Python, I should know this. So that should work. Else, if it's less than k, then we can set max index to I. Okay, this would work for... Okay, so min index equals I here, right? As well as max index equals I there, right? Else we can set max index to here. And we also... We're gonna optimize this once we actually complete it, but let's just see what this returns. Return length of result. What does result even look like? Current result. It just looks like 1, 2, and 3, which is good because that's the first part. But now we need 5 and 6. Let's for each one, let's print sorted nums max min index sorted nums max index for every iteration. Okay, sure. 1, 2, 1, 3, 1, 5, 6, 6. Okay, 1, 2, 1, 3. The current difference is sequence min. We're not even using sequence min though. What? That's the only place we have sequence min in. But we don't even need this though. Because since we're looking at a sorted array, each new element is going to be the new max. Minus sorted nums min index, right? Okay, that's better. Okay, no, why is it 1, 2? Why is it 1 and 2? One, 2, 1, 3. We should probably do it up here though. 1, 1, 1, 2, 1, 3, 5, 5. Okay, if I print it here, the only elements that should show up are 1 and 5. Why is it not even showing 1 and 5 though? Why does it show 1 and 3? Current difference. Okay, let's print this and current difference. Sorted nums I. So we're looking at here, right? Minus sorted nums min index. Okay. Sure. That's difference of 1. No, it's probably more accurate if we do this, right? right? Something's not adding up here. Current difference equals the current element we're looking at minus the minimum number we have, right? So yeah, it's the current difference is 1 when we're looking at 2 and 1. If current difference is greater than k, 1 is not greater than 2. So we set max index to I. So max index equals it should be 1 now. Oh. We should probably just do min index and max index here. Min index, max index. I think that'd make me understand it more. So we're looking at the first and second elements. The difference is 1, yeah. Now we're looking at 3 and 1. The difference is 2. Now we're looking at 5 and 1. Why did this? Why after 0 and 2? Oh, because it... Okay, so wait. 2 and 1. Difference is 1. It sets the max index to 1 now. Now it's 3 and 1. The current difference is 2. 2 is not greater than 2. So we set the max index to 2 now. And that's right. Next time through, we're looking at 5 and 1, right? We're looking at 5 and 1. This is greater than k. So we add it should be plus 1, right? Because this is exclusive, and we have an updated max index. And then we set both now 0, 1, 2, 3. Now it's 5 and 5, right? Why is the difference? Do we need to... Okay, but this should not matter though, because that's not doing anything, right? Now it's looking at 5 and 6, the difference is 1. I really don't understand why this is not working. Oh. And then we probably need a if I equals length of sorted nums minus 1, then result dot append please. Please, 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 please. We passed most test cases. I'm happy with that. I'm hoping all of these are just edge cases. This is obviously an edge case. We have one number, 0, k equals 0. Why are we, okay. That's probably just an edge case we can put up here. If length of nums is less than 2, then return 1. Hey, we did it. We passed somehow, some way. Definitely not efficient. Maybe we can try a little optimization here. God, that took us a long time. Holy crap. Okay, I see an optimization right away. We don't need another array. We don't need an array at all actually. We can just have a variable called result equals 0, and then instead of doing this, we can do result plus equals 1, and then we can return result, and same here, result plus equals 1. This should work as well, and it is faster. Still not fast enough though. Or can we get rid of this and just do return result plus 1? Okay, okay. There we go. And we could do that because always at the end. Yeah. Always at the end of the array. There's going to be an extra array you have to create. Because if it's greater, the difference between the last two elements or so or whatever is greater than k, then you obviously just add this to the result as we see up here. If it's less than k, then we don't actually have anything up here to add it to the result. So in both cases we're needing to add 1 to the result. I'm interested to see how you can optimize this further though. I'd say I'm proud of this solution. Could you do just replace this variable instead of this? I mean, No, it looks way worse. Okay. Yep, we'll stick with this. I like it, I like it. Let's see what everyone else did. They sorted it. You can initialize answer to 1. That's smart, actually. X equals the first element. Brian range there. If nums I minus x equals nums I. What? If the current element we're looking at minus x, if the current element we're looking at, so we're starting at the second element, right? Why are we, oh, yeah, you're sorting it there. And you can do that because you're not needing to return it. You're not needing to return a separate an array, like I somehow thought at the start. But this is clean. This is clean. Let me try to understand it. You're starting at the second element. This is sorted, so it's looking like this, right? X is initialized as the first element. If 2 minus 1 is greater than k, it's not. Okay. Oh my gosh. Wait, that's actually beautiful. You're not doing anything. You have this as min, and you have this as max, but you're not doing anything until you come across a difference where 5 minus 1 is greater than k. And once this happens, you just add 1 to the answer and you set the minimum to 5. That is so beautiful. Oh my god, this is art. This is honestly art. Like that, like after like thinking through this problem for so long and then seeing the solution is that easy. But it's not even that easy, it's just beautiful and simple, and that's what I love about this. So they start out by sorting the array in place. They have x equals nums 0, the first element. This is just the minimum. It's just keeping track of the minimum value of each subsequence. And then you go from the second element to the last element. And then if the current element we're looking at minus the minimum is greater than k, then all we want to do is set x to the first element where it's greater, and then just add 1 to the answer. Or, I already explained this +1 thing. They did something, I think, more clever, which is just initializing it as 1 at the start, so you don't have to add 1 at the end, that's also an amazing optimization. You set this, and then you add 1 here, and that's literally all you need to do. And then return answer. Such a good, so nice, so beautiful. Wow. That's crazy. Okay, let's see what these crazy people, yeah. And they didn't even need, oh my god. That also works for the edge case where there's only one element in the array, because you're initializing as 1. That's awesome. How is there something faster than that? Let me see this. What the fuck is this? Nums equals sorted list set. What does that even do? Alright, this would, I mean, you wouldn't even want this as your code. I mean, it may be faster, but like, you want readable code, and I don't even understand what this is doing. Why does converting it to a set make it faster? Because that's the only reason why one would do this. I don't know. Alright. That's the end of this problem. It was that optimized code was amazing. But cool. See you tomorrow, guys.